In this video, we present an application of the Jellyfish matrix completion framework to the problem of large-scale seismic data interpolation. Acoustic seismic surveys allow the energy industry to look below the surface of the Earth in their quest to find oil and natural gas reserves. Such surveying methods generate data that's large, noisy, and incomplete, and requires one to solve a difficult interpolation problem. This video describes how we used Jellyfish, developed at the University of Wisconsin, to solve such interpolation problems with comparable accuracy to state-of-the-art approaches for marine surveys, but with dramatically higher efficiency. To locate oil deposits beneath the Earth's surface, oil exploration companies carry out marine seismic surveys that consist of a series of acoustic experiments. This map shows a seabed which is divided into individual regions. In some regions, a survey ship conducts an experiment. An experiment is conducted using an acoustic transmitter called the source, capable of generating seismic waves. The survey ship also tows an array of receivers that sense the variation in pressure caused by these seismic waves. In each experiment, the source generates a seismic wave that travels through the Earth's surface. When the wave encounters a boundary between two different materials, part of the wave is reflected back towards the surface. Each receiver on the surface detects the reflected wave and records the time when it arrives. The measurements collected from the receivers yield a shot image, which is the result of the experiment. Geologists use these shot images to deduce the composition of the seabed, including whether or not it contains oil. However, due to physical and economic constraints, this experiment is not conducted in each region. In order to study the entire seabed, geologists must interpolate the shot images for the unexplored regions. Some properties of seismic data make this interpolation process challenging. Specifically, the data is high-dimensional, and receivers record many measurements, generating terabytes of data that need to be analyzed. To interpolate the missing seismic data, we use a two-step algorithm. The first step transforms the seismic data into a matrix that is in the appropriate form for Jellyfish to complete. In the second step, we complete the matrix using Jellyfish. Seismic data is naturally high-dimensional since the data is indexed by the x and y coordinates of the source and receiver associated with each measurement. This seismic data's natural representation is as a four-dimensional tensor. However, using a simple transformation, we represent the seismic data as a matrix. We perform this transformation by looking at a single source coordinate which corresponds to a shot image. Think of this image as lying on a grid indexed by the source coordinates. We populate this grid with the remaining shots and we obtain an extensive, incomplete image that can be naturally represented as a matrix. By transforming the data into a matrix, the tensor completion problem becomes a matrix completion problem. Since this matrix representation is low rank, we can use matrix completion tools like Jellyfish to interpolate the missing data. After transforming the seismic data into a matrix, we use Jellyfish to complete it. Jellyfish is a framework that completes matrices, assuming they're low rank. The output of Jellyfish is a compact factorized representation of the completed image. An unmeasured shot can be obtained by simply multiplying the factors. To evaluate our method, we performed experiments on a sample dataset. We interpolate the corresponding shot for each source coordinate pair on the 54 by 54 source grid using the 200 available shots. On the right, you see a small portion of the image completed by Jellyfish. Interpolation of a single shot from the test set reveals that Jellyfish can successfully interpolate a missing shot with a high signal-to-noise ratio, whereas the freely available in-way toolbox fails to interpolate the missing shot. In this video, we've presented an application of Jellyfish to the problem of large-scale seismic data interpolation. Keep in mind that Jellyfish is a general, scalable matrix completion framework with many applications. Using a simple transformation, seismic data can be represented as a matrix and successfully completed using Jellyfish. You can download Jellyfish and the example dataset from the Hazy Group website.